Right, so one more question. Let's go through how you calculate how many more times effective concentration D is than concentration B. So you can see from these zones of inhibition, these clear zones, that D has got a much bigger zone than B, therefore D is going to be more effective. How much more effective is it? Well, we need to calculate the area of these discs. And if you remember, to calculate area, we need to do pi r squared. So what we need to calculate is the square of the radii of B and D, and then multiply them by pi. So if we take a measurement across B, okay, when I measured across B, I found out that my measurement was that B was 13 millimeters. So if the diameter of B is 13, that means that the radius is equal to 6.5 millimeters. I'm doing it in millimeters. You could do it in centimeters if you wanted to. Okay, looking at D, my diameter when I measured all the way across the largest part of the circle, the middle of the circle, I got 22 millimeters. So that means for me, the radius is equal to 11 millimeters. Okay, so if I'm going to do pi r squared for B, so B is going to be pi 6.5 squared, and D is going to be pi 11 squared. And for B, I get 133 units, please, millimeters squared. And for D, I get 380 millimeters squared. How much bigger is D than B? Well, that's going to be a ratio. So if I want to know how much bigger D is than B, we're looking at dividing them by one another. And obviously we've got the units there, oopsie daisy, which will cancel each other out. And so we end up with a value of 2.85. So that means that D is 2.85 times more effective than B in killing these bacteria. But you will notice that if you did some calculations just using the diameter of the circles, I think maybe you got 1.6. If you did the same thing just using diameters, you did get 1 mark. So it's really important that you do your working so that you have the best chance of getting any mark for your maths. All right, thank you.